Hello and welcome. In this video, we'll be discussing equations of parallel lines, and then we'll move on to figuring out the equation of perpendicular bisectors. So let's get into it. Equations of parallel lines are rather simple because what's the gradient of two parallel lines? If you consider one line to have a gradient of, let's say, this gradient of this line is 3 over 2, and I'm telling you there is another one. So this is line 1, and there is another line 2, and they are parallel with each other. Okay, so this is notation line 1. If you don't see this notation in your book, but this vertical lines is saying line 1 and line 2 are parallel. So what's the gradient of this line here? M here is what? The gradient of line 2 is also the same gradient. The gradient is 3 over 2. So that's the simplicity of this part. That's why I'm doing these two exercises in one go. So in this example, we've been told the line is parallel to 3x plus 6x plus 3y minus 2 equal to 0 and passes through 3 comma 5. Find the equation of the line. So first we need to know what's the gradient of this line here. What is the gradient? And then we can use it with this coordinate and this equation that I showed you previously. I've written the equation up there, so we're going to use that in the second stage of solving this problem. So let's figure out the gradient. First, figure out the gradient, and the intercept is not so important. Make y the subject of that equation. So let's just have a go at it, pause the video, rearrange it quickly to figure out y on one side. So we will have 3y equals to minus 6x plus 2. Then divide both sides by 3. So you get negative 6 divided by 3 and 2 over 3. So this gradient is negative 2, and the intercept is 2/3. We are mainly concerned with this gradient here. Alright, so we wanted to figure out the gradient, we did that. Now we are going to use this formula with the coordinate of 3 comma 5, because that's what we've been told in the question. The new line that we're figuring out the equation to is having gradient of minus 2 and coordinate of 3 comma 5. So substitute it into that equation. Y minus 5 equals to minus 2, open a bracket, x minus 3. Now multiply out this bracket. I'm going to write minus 2x plus 6 and then add 5 from the left. So combining those together, minus 2x plus 11 is the equation of the line they want us to find. So let's look at this is the only example for parallel lines. Good luck practicing the exercise 5e. I'll show you what you need to do for 5f next. Alright, for finding equations of perpendicular bisectors, it's important that you know how to figure out the midpoint of any line segment. So if we know the coordinates of A and B here, we need to calculate the midpoint, because the word perpendicular bisector means that figuring out the equation of a line that's perpendicular to A to B and intersecting. Bisect means divide into two, divide in half, right? If I can spell divide, is divide in half. So we need to know what is the midpoint of the line segment there. So looking at the gradient of A, I'll show you visual on this example why we do what we do. Look at the y coordinates and x coordinates. The y coordinate of midpoint is exactly halfway between these two y values, and the x coordinate is exactly halfway between the x values here. So basically midpoint is the average of x's and average of y's. Now there's only 2 points here, so you add x values and divide by 2. That's why the equation is like so. Then you put the comma, and then you add y values and divide them by 2. So you're really taking the average of y values and average of x values. Because there's 2 points, you divide by 2. All right. So in this example, if we finish it off, we take x values to be, let's just write 1 comma, no, sorry, 2 is the x value, 1 is the y value, and here we got 8 comma 5, right? So the average of x values comes first. You say 8 plus 2 divided by 2, comma, then average of y values, 5 plus 1 divided by 2. Then 10 over 2 is a 5, 6 over 2 is a 3. And you can read it from the graph as well. In most cases, we cannot read it off the graph, but this is to confirm that what we found is correct. All right? So let's look at how to figure out the gradient of perpendicular lines now. We know how to figure out how the midpoint, coordinate of the midpoint. Now, if you have have the gradient of line 1 here, you can figure out the gradient of line 2 if you've been told they are perpendicular to each other. Let's just consider this gradient of line 1. What is the gradient of line 1? You can read it from this triangle here, is a over b, right? What's the gradient of line 2 there? It's changing y over changing x. So line 2 has gradient of m2, which is minus b over a. Changing y is minus b, changing x is a. So what do you notice about these two gradients? They kind of they have the same, they're similar, but they're reciprocal of each other, and one is negative, one is positive. Now, if you notice, if we take m1 and multiply it by m2, what do we get? A over b times by negative b over a will give us, the cancellations will give you a minus 1. Okay? So any two perpendicular gradients, no matter what, if these two lines are perpendicular to each other, the product of their gradient is going to be a minus 1. That means that we can, if we know one of these gradients that, and we're looking for the other, let's say we know m1 but we're looking for m2, we can do divide both sides by m1 will give us this. So if I have a minus 1, well, if I have m1, I can figure out m2 by just saying minus 1 divided by m1 is m2. All right? So let's see an example. I'm gonna wipe off my writing here, and you can remember what I just said. So look, what I said was that the product of the two gradients is always equals to minus 1. So if you want to know the perpendicular gradient, you take one of the gradients and you take minus 1 and you put it on top of the other gradient. So this is a bit strange. Let's say we know the gradient is minus half, and we're going to figure out the perpendicular gradient here. So when m1 is a minus half, we want to know what m2 is. What is m2? M2, we start by writing minus 1 divided by negative half. So dividing by a fraction means multiplying by its reciprocal. So minus and a minus cancel. So it's the same as saying 1 times reciprocal of a half is a 2 over 1. 1 times 2 over 1 is just 2. So in effect, the shortcut is if you have one gradient that is 3/4, right? Let's say m1 is 3/4, m2, I can figure it out in my head by turning this fraction, writing its reciprocal, and putting a negative, multiplying by negative. I'm going to say its negative reciprocal is going to be negative 4 over 3. And if I had m1 to be a negative fraction, like let's say 5 over 3, then m2 would be positive 3 over 5. Okay, the signs have to be different. Alright, so let's look at this example. We've been told to what are these two lines perpendicular? Just to identify the gradients and compare them with each other. Let's say this line is y equals to, adding y to the right will give us y equals to 3x minus 2. So we know the gradient here is 3. Let's find the gradient here. Let's add 3y to both sides. So sorry, take away 3y. So I'll have a negative 3y here, and then divide by minus 3. So that would mean that I have a 1/3 in front of x minus 6 equal to y. So multiplying out the bracket, I'll get negative a third x plus 2. So y is this. So I'm comparing this gradient here to this gradient here. Now, if I'm not sure, I just multiply them. I say, what's the product of 3 times minus a third? Wow, it's a minus 1. It fits the formula. So they are perpendicular. Right? They are perpendicular. Okay? Let's look at the next example. In this question, we've been asked, are these two lines perpendicular? So we don't have to rearrange this equation. This is the gradient. Now you do need to rearrange this equation. So you get 2x plus 4 equals to y. So I could have written y on the left, right? So y is 2x. So the gradient here is 2, and the gradient there is a half. You might be tricked into thinking yes they are, but they're not, because one is 2 and one is a half. Both of these gradients are positive, right? The sign needs to be different. So you will say half times 2 is 1, and that is not, this is not the minus 1, so they're not perpendicular. Alright, so let's look at the next example. In this question, we've been told a line is perpendicular to this equation, the another line with this equation, and it passes through this coordinate. We've been asked to figure out the equation of the new line going through this coordinate. So first, rearrange this equation and figure out what's the gradient. Alright, so let's just say 2y equals to x plus 8, adding x and 8 to both sides, and divide by 2, so the gradient is half x plus 4. The gradient is a half. We mainly concerned with this number, this gradient. Now, because we've been told that perpendicular, m2 is negative reciprocal of a half. I'm just gonna write it out so if you don't know why. So the perpendicular gradient is negative, negative a 2. So I'm gonna use the equation of a straight line now. If you don't remember, you take y, take away the y-intercept, minus 7. Sorry, that's not the y-intercept, that's just the y-coordinate. And then we're gonna use the gradient here, open a bracket, x minus the gradient of this point, the x coordinate is 5. I'm going to put it there and expand the bracket and simplify. So I'll have negative 2x plus 10 here on the right. Now I'm going to, because this is a plus 7, I'm going to subtract 7 from 10 and write y here. So y is negative 2x plus 3. This is the equation of the line we've been asked to calculate. So as you see here is negative 2x plus 3, as we found out. Okay, so perpendicular bisector. I went through this example at the beginning of the lecture, and we did find out. So remember this formula for midpoint. We're going to use it next to figure out equation of perpendicular bisector. Here, this example here is asking us part A to figure out the midpoint, which we just did. We took the average of x values and we took average of y values, and that's 5 comma 3 here. Now part B of this example is saying figure out the equation of perpendicular bisector. Right, so now we're going back to figure out the gradient of A to B, and then we're going to figure out the perpendicular gradient. This perpendicular line, red line, is perpendicular to AB, right? Perpendicular bisector. Alright, so what's the gradient of A to B? A to B, if we subtract y's and divide by x, so 5 minus 1, we're taking the y values here, 5 minus 1, and dividing it by x values, 8, the difference between x values, 8 minus 2. So 4 divided by 6 is 2/3. Now, what's the perpendicular gradient? This is the gradient of the A to B. Alright, A to B. So perpendicular gradient M2 is going to be negative of 3 over 2. We could put minus 1 and say let's divide minus 1 by 2/3. We will get negative 3 over 2. Then we're going to take the equation of a straight line. I'll show you. So this equation, and substitute the midpoint and the gradient we just found. Okay, so the midpoint was 5 comma 3. Yeah, remember what we found here? The midpoint, you need to use midpoint here. Don't forget, don't take A or B. All right, bisector means that you will go through halfway between A or B. So then we taking 3 and 5, and I've color coded these values so you know where they came from. Alright, so multiplying at the bracket, minus 3 over 2 times minus 5 give you plus 5, 15 over 2, and then add 3 to both sides. I'm writing 3 as 6 over 2, and it simplifies to this equation down here. Alright, pause the video, make notes of this, because you're going to have to do this quite a lot in the exercise. Alright, so good luck, have a go at this exercise. I'll see you in the next video.